So far, all in all, on-chain governance seems like a very good bargain. So what's wrong with it? Welcome to Ethereum Audible. I am Yoshua Zlatogorsky, and welcome back to another read-through of a critical piece of the Ethereum ecosystem. Today we are going back in time, back all the way to December of 2017, which is 4 years ago, and in crypto years, that's probably 50 at least, but this piece is just as relevant today as it was then, and it is called Notes on Blockchain Governance by Vitalik Buterin. And why it's relevant today is because this piece dives into how blockchains help governance and how tokens and governance are related. This past week, we've seen something amazing in the Web3 world, and that was the formation of the Constitution DAO, a DAO that literally formed within a week, and within 2 weeks funded $40 million of donations to buy the last privately held copy of the United States Constitution at a Sotheby's auction. And even though the DAO lost the auction, in full disclosure, I put some money in. I really wanted to see it work out, but it didn't work out. But the point remains the same, that this DAO got spun up out of nothing. $40 million of ETH was committed to this. And in return, the people who were committing were not getting a fraction of the Constitution. They weren't owning a part of an NFT or something secured in a smart contract. No, they were getting tokens in a DAO, in some governance structure that would then decide on what this group, this DAO, would do with the Constitution. And your say as a participant in this DAO would be based on the tokens that you owned, which was based on the donation. And so the question of blockchain governance, tightly coupled on-chain voting to the tokens you own, is one that's just as relevant today as when this piece came out 4 years ago. And that's why I wanted to dive into this question of blockchain governance, DAOs, decentralization. Is it really decentralized? And there have been some great pieces on this by Vitalik, by other people in the ecosystem, and we will be reading through them over the next few months because this is just an incredibly important topic to think deeply about. And so we're going to start with Notes on Blockchain Governance by Vitalik Buterin from December 17th of 2017. But first, I want to thank the sponsors that make this episode possible. This episode is brought to you by Alpe Audio. Want to learn on the go but need more depth than a podcast? Alpe is the app for you. It's an audio education app that brings great in-depth courses that are as fun as podcasts but as educational as a degree. Each lesson comes with summaries, additional resources, flashcards, and more. You can even find Ethereum Audible on Alpe with all of those additional resources. If you want to check it out, head over to get.alpeaudio.com, and that's A-L-P-E, Alpe, A-L-P-E. Let's go. Notes on Blockchain Governance by Vitalik Buterin, in which I argue that tightly coupled on-chain voting is overrated. The status quo of informal governance as practiced by Bitcoin, Bitcoin Cash, Ethereum, Zcash, and similar systems is much less bad than commonly thought. That people who think that the purpose of blockchains is to completely expunge soft, mushy human intuitions and feelings in favor of completely algorithmic governance, emphasis on completely, are absolutely crazy. And loosely coupled voting, as done by carbon votes and similar systems, is underrated, as well as describe what framework should be used when thinking about blockchain governance in the first place. One of the more interesting recent trends in blockchain governance is the resurgence of on-chain coin holder voting as a multi-purpose decision mechanism. Votes by coin holders are sometimes used in order to decide who operates the supernodes that run a network. for example, a delegated proof of stake in EOS, NEO, Lisk, and other systems. Sometimes to vote on protocol parameters, for example, the Ethereum gas limit, and sometimes to vote on and directly implement protocol upgrades wholesale, for example, Tezos. In all of these cases, the votes are automatic. The protocol itself contains all of the logic needed to change the validator set or to update its rules, and does this automatically in response to the result of the votes. Explicit on-chain governance is typically touted as having several major advantages. First, unlike the highly conservative philosophy espoused by Bitcoin, it can evolve rapidly and accept needed technical improvements. Second, by creating explicit decentralized net framework, it avoids the perceived pitfalls of informal governance, which is viewed to either be too unstable and prone to chain splits, or prone to becoming too de facto centralized, the latter being the same argument made in the famous 1972 essay, Tyranny of Structurelessness. Quoting the Tezos documentation, quote, "While all blockchains offer financial incentives for maintaining consensus on their ledgers, no blockchain has a robust on-chain mechanism that seamlessly amends the rules governing its protocol and rewards protocol development. As a result, first-generation blockchains empower de facto centralized core development teams or miners to formulate design choices." End quote. And, quote, "Yes, but why would you want to make a minority chain split easier? Splits destroy network effects." End quote. On-chain governance used to select validators also has the benefit that it allows for networks that impose high computational performance requirements on validators without introducing economic centralization risks and other traps of that kind that appear in public blockchains, for example, the validator's dilemma. So far, all in all, on-chain governance seems like a very good bargain. So what's wrong with it? What is blockchain governance? To start off, we need to describe more clearly what the process of blockchain governance is. Generally speaking, there are two informal models of governance that I will call the decision function view of governance and the coordination view of governance. The decision function view treats governance as a function. A function of x1, x2 will lead to y, where the inputs are the wishes of various legitimate stakeholders, for example, senators, the president, property owners, shareholders, voters, etc., and the output is the decision. The decision function view is often useful as an approximation, but it clearly frays very easily around the edges. People often can and do break the law and get away with it. Sometimes rules are ambiguous, and sometimes revolutions happen. And all three of these possibilities are, at least sometimes, a good thing. And often, even behavior inside the system is shaped by incentives created by the possibility of acting outside the system. And this, once again, is at least sometimes a good thing. The coordination model of governance, in contrast, sees governance as something that exists in layers. The bottom layer is, in the real world, the laws of physics themselves. As a geopolitical realist would say, guns and bombs. In the blockchain space, we can abstract a bit further and say that it is each individual's ability to run whatever software they want in their capacity as a user, miner, stakeholder, validator, or whatever other kind of agent a blockchain protocol allows them to be. The bottom layer is always the ultimate deciding layer. If, for example, all Bitcoin users wake up one day and decide to edit their client source code and replace the entire code with an Ethereum client that listens to balances of a particular ERC20 token contract, then that means that the ERC20 token is Bitcoin. The bottom layer's ultimate governing power cannot be stopped, but the actions that people take on this layer can be influenced by the layers above it. The second and crucially important layer is coordination institutions. The purpose of a coordination institution is to create focal points around how and when individuals should act in order to better coordinate behavior. There are many situations, both in blockchain governance and in real life, where if you act in a certain way alone, you are likely to get nowhere, or worse. But if everyone acts together, a desired result can be achieved. In these cases, it's in your interest to go if everyone else is going, and stop if everyone else is stopping. You can think of coordination institutions as putting up green or red flags in the air, saying go or stop, with an established culture that everyone watches these flags, and usually does what they say. Why do people have the incentive to follow these flags? Because everyone else is already following these flags. And if you have the incentive to do the same thing as what everyone else is doing. In the real world, military orders from a general function as a flag, and in the blockchain world, the simplest example of such a flag is the mechanism that tells people whether or not a hard fork is happening. Coordination institutions can be very formal, or they can be informal, and often give suggestions that are ambiguous. Flags would ideally always be either red or green, but sometimes a flag might be yellow, or even holographic, appearing green to some participants and yellow or red to others. Sometimes there are also multiple flags that conflict with each other. The key questions of governance thus becomes, what should layer 1 be? That is, what features should be set up in the initial protocol itself, and how does this influence the ability to make formulaic, as in decision function-like, protocol changes, as well as the level of power of different kinds of agents to act in different ways. 2. What should layer 2 be? That is, what coordination institutions should people be encouraged to care about? The role of coin voting. Ethereum also has a history with coin voting, including DAO proposal votes, the DAO carbon vote, and the EIP 186 or 649 or 669 carbon vote. These 3 are all examples of loosely coupled coin voting, or coin voting as a layer 2 coordination institution. Ethereum does not have any examples of tightly coupled coin voting, or coin voting as a layer 1 in protocol feature, though it does have an example of tightly coupled miner voting. Miners' rights to vote on the gas limit. Clearly, tightly coupled voting and loosely coupled voting are competitors in the governance mechanism space, so it's worth dissecting. What are the advantages and disadvantages of each one? Assuming zero transaction costs, and if used as a sole governance mechanism, the two are clearly equivalent. If a loosely coupled vote says that change X should be implemented, then that will serve as a green flag, encouraging everyone to download the update. If a minority wants to rebel, they will simply not download the update. If a tightly coupled vote implements change X, then the change happens automatically. And if a minority wants to rebel, they can install a hard fork update that cancels the change. However, there clearly are non-zero transaction costs associated with making a hard fork, and this leads to some very important differences. One very simple and important difference is that tightly coupled voting creates a default in favor of the blockchain adopting what the majority wants, requiring minorities to exert great effort to coordinate a hard fork to preserve a blockchain's existing properties. Whereas loosely coupled voting is only a coordination tool and still requires users to actually download and run the software that implements any given fork. But there are also many other differences. Now let us go through some arguments against voting and dissect how each argument applies to voting as layer 1 and voting as layer 2. Low voter participation. One of the main criticisms of coin voting mechanisms so far is that no matter where they are tried, they tend to have very low voter participation. The DAO carbon vote only had a voter participation rate of 4.5%. Additionally, wealth distribution is very unequal, and the result of these two factors together are best described by this image created by a critic of the DAO fork. And the image describes that only a tiny fraction of the total Ether supply voted for the DAO fork, and of that total Ether supply that voted, which was a small sliver, one voter made up around a sixth. And so this image really brings to life the challenge when such a small amount of people vote and there's one voter who owns such a large portion of the voting token. The EIP 186 carbon vote had 2.7 million ETH voting. The DAO proposal votes did not fare better, with participation never reaching 10%. And outside of Ethereum, things are not sunny either. Even in BitShares, a system where the core social contract is designed around voting, the top delegate in an approval vote only got 17% of the vote, and in Lisk it got up to 30%. Though as we will discuss later, these systems have other problems of their own. Low voter participation means two things. First, the vote has a harder time achieving a perception of legitimacy, because it only reflects the views of a small percentage of people. Second, an attacker with only a small percentage of all coins can sway the vote. These problems exist regardless of whether the vote is tightly coupled or loosely coupled. Game theoretic attacks. Aside from the quote big hack that received the bulk of the media attention, the DAO also had a number of much smaller game theoretic vulnerabilities. This article from Hacking Distributed does a good job of summarizing them, and I will put that in the show notes. But this is only the tip of the iceberg. Even if all of the finer details of a voting mechanism are implemented correctly, voting mechanisms in general have a large flaw. In any vote, the probability that any given voter will have an impact on the result is tiny, and so the personal incentive that each voter has to vote correctly is almost insignificant. And if each person's size of the stake is small, their incentive to vote correctly is insignificant squared. Hence, a relatively small bribe spread out across the participants may suffice to sway their decision, possibly in a way that they collectively might quite disapprove of. Now, you might say people are not evil, selfish, profit maximizers that will accept $50 bribe to vote to give $20 million to Josh Arza just because the above calculation says their individual chance of affecting anything is tiny. Rather, they would altruistically refuse to do something that evil. There are two responses to this criticism. First, there are ways to make a bribe that are quite plausible. For example, an exchange can offer interest rates for deposits, or even more ambiguously, use the exchange's own money to build a great interface and features, with the exchange operator using the large quantity of deposits to vote as they wish. Exchanges profit from chaos, so their incentives are clearly quite misaligned with users and coin holders. Second, and more damningly, in practice it seems like people, at least in their capacity as crypto token holders, are profit maximizers, and seem to see nothing evil or selfish about taking a bribe or two. As Exhibit A, we can look at the situation with Lisk, where the delegate pool seems to have been successfully captured by two major political parties that explicitly bribe coin holders to vote for them, and also require each member in the pool to vote for all the others. And here Vitalik links to a few images that show this practice happening explicitly in Lisk GDT, and the actual transactions on the blockchain. Here note that there is a key difference between tightly coupled and loosely coupled votes. In a loosely coupled vote, direct or indirect vote bribing is also possible, but if the community agrees that some given proposal or set of votes constitutes a game theoretic attack, they can simply socially agree to ignore it. And in fact, this has kind of already happened. The carbon vote contains a blacklist of addresses corresponding to known exchange addresses, and votes from these addresses are not counted. In a tightly coupled vote, there is no way to create such a blacklist at protocol level, because agreeing who is part of the blacklist is itself a blockchain governance decision. But since the blacklist is part of a community-created voting tool that only indirectly influences protocol changes, voting tools that contain bad blacklists can simply be rejected by the community. It's worth noting that this section is not a prediction that all tightly coupled voting systems will quickly succumb to bribe attacks. It's entirely possible that many will survive for one simple reason. All of these projects have founders or foundations with large pre-mines, and these act as a large centralized actors that are interested in their platform's success, that are not vulnerable to bribes, and hold enough coins to outweigh most bribe attacks. However, this kind of centralized trust model, while arguably useful in some contexts in a project's early stages, is clearly one that is not sustainable in the long term. Non-representativeness. Another important objection to voting is that coin holders are only one class of user, and may have interests that collide with those of other users. In the case of pure cryptocurrencies like Bitcoin, store of value use, hodling, and medium of exchange use, buying coffees, are naturally in conflict, as the store of value prizes security much more than the medium of exchange use case, which more strongly values usability. With Ethereum, the conflict is worse, as there are many people who use Ethereum for reasons that have nothing to do with either, see CryptoKitties, or even value-bearing digital assets in general, see ENS. Additionally, even if coin holders are the only relevant class of user, one might imagine this to be the case in a cryptocurrency where there is an established social contract, that its purpose is to be the next digital gold and nothing else. But there is still the challenge that a coin holder vote gives a much greater voice to wealthy coin holders than to everyone else, opening the door for centralization of holdings to lead to unencumbered centralization of decision-making, or in other words, what happened in the Ethereum DAO fork. And if you want to see a review of a project that seems to combine all of these disadvantages at the same time, see this. And there's a link to btcgeek.com BitShares trying memory coined year ago disastrous ends. And even though this link is from 4 years ago, it's still an interesting read. This criticism applies to both tightly coupled and loosely coupled voting equally. However, loosely coupled voting is more amenable to compromises that mitigate its unrepresentativeness, and we will discuss this more later. Centralization. Let's look at the existing live experiment that we have in tightly coupled voting on Ethereum, the gas limit. Here's the gas limit evolution over the past 2 years. And you might notice that the general feel of the curve is a bit like another chart that may be familiar to you. And here there are 2 images. One is of the Ethereum average gas limit from October 2015 to October 2017, compared to the top marginal income tax rate from 1913 to 2003, comparing the gas limit of Ethereum on average to that top marginal income tax rate. Basically, they both look like magic numbers that are created and repeatedly renegotiated by a fairly centralized group of guys sitting together in a room. What's happening in the first case? Miners are generally following the direction favored by the community, which is itself gauged via social consensus aids similar to those that drive hard forks. Is it core developer support, Reddit upvotes, etc.? In Ethereum, the gas limit has never gotten controversial enough to require anything as serious as a coin vote. Hence, it's not at all clear that voting will be able to deliver results that are actually decentralized if voters are not technically knowledgeable and simply defer to a single dominant tribe of experts. This criticism, once again, applies to tightly coupled and loosely coupled voting equally. Update. Since writing this, it seems like Ethereum miners managed to up the gas limit from 6.7 million to 8 million, all without even discussing it with the core developers of the Ethereum Foundation. So there is hope, but it takes a lot of hard community building and other grueling non-technical work to get to that point. Digital constitutions. One approach that has been suggested to mitigate the risk of runaway bad governance algorithms is digital constitutions that mathematically specify desired properties that the protocol should have and require any new code changes to come with a computer verifiable proof that they satisfy these properties. This seems like a good idea at first, but this too should, in my opinion, be viewed skeptically. In general, the idea of having norms about protocol properties and having these norms serve the function of one of the coordination flags is a very good one. This allows us to enshrine core properties of a protocol that we consider to be very important and valuable, and make them more difficult to change. However, this is exactly the sort of thing that should be enforced in loosely coupled, i.e. layer 2, rather than tightly coupled, layer 1 form. Basically, any meaningful norm is actually quite hard to express in its entirety. This is part of the complexity of value problem. This is true even for something as seemingly unambiguous as the 21 million coin limit. Sure, one can add a line of code saying, assert that the total supply is less than 21 million, and put a comment around it saying, do not remove at all costs. But there are plenty of roundabout ways of doing the same thing. For example, one could imagine a soft fork that adds a mandatory transaction fee. This is proportional to coin value times the time since the coin were last sent. This is equivalent to demurrage, which is equivalent to deflation. One could also implement another currency called BJT coin with 21 million new units and add a feature where if a Bitcoin transaction is sent, the miner can intercept it and claim the Bitcoin instead of giving the recipient BJT coin. This would rapidly force Bitcoins and BJT coins to be fungible with each other, increasing the total supply to 42 million, without ever tripping up that line of code. Softer norms like not interfering with application state are even harder to enforce. We want to be able to say that a protocol change that violates any of these guarantees should be viewed as illegitimate. There should be a coordination institution that waves a red flag, even if they get approved by a vote. We also want to be able to say that a protocol change that follows the letter of a norm but blatantly violates its spirit, the protocol change should still be viewed as illegitimate. And having norms exist on layer 2 in the minds of humans in the community rather than in the code of the protocol best achieves that goal. Towards a balance. However, I am also not willing to go the other way and say that coin voting or other explicit on-chain voting-like schemes have no place in governance whatsoever. The leading alternative seems to be core developer consensus. However, the failure mode of a system being controlled by ivory tower intellectuals who care more about abstract philosophies and solutions that sound technically impressive over and above real day-to-day concerns like user experience and transaction fees is, in my view, also a real threat to be taken seriously. So how do we solve this conundrum? Well, first we can heed the words of Slate Star Codex in the context of traditional politics. Quote, "The rookie mistake is, you see that some system is partly Moloch, i.e. captured by misaligned special interests. So you say, okay, we'll fix that by putting it under the control of this other system. And we'll control this other system by writing, do not become Moloch on it in bright red marker. I see capitalism sometimes gets misaligned, let's fix it by putting it under the control of the government. We'll control the government by having only virtuous people in the high office." I'm not going to claim that's a great alternative, but the occasionally adequate alternative is the neoliberal one. Find a couple of elegant systems that all optimize along different criteria, approximately aligned with the human happiness, pit them off against each other in a structure of checks and balances, hope they screw up in different places, like in that Swiss cheese model, keep enough individual free choice around the people so that they can exit any system that gets too terrible, and let cultural evolution do the rest. End quote. In blockchain governance, it seems like this is the only way forward as well. The approach for blockchain governance that I advocate is multifactorial consensus, where different coordination flags and different mechanisms and groups are polled, and the ultimate decision depends on the collective results of all of these mechanisms together. These coordination flags may include 1. The roadmap, i.e. the set of ideas broadcasted earlier on in the project's history about the direction of the project that it should be going. 2. Consensus among the dominant core development teams. 3. Coin holder votes. 4. User votes through some kind of Sybil-resistant polling system. And 5. Established norms. Example, a non-interference with applications like the 21 million coin limit for Bitcoin. I would argue that this is very useful for coin voting to be one of the several coordination institutions deciding whether or not a given change gets implemented. It is an imperfect and unrepresentative signal, but it is a Sybil-resistant one. If you see 10 million ETH voting for a given proposal, you cannot dismiss that by simply saying, oh, that's just hired Russian trolls with fake social media accounts. It is also a signal that is sufficiently disjoint from the core development team that if needed, it can serve as a check on it. However, as described above, there are very good reasons why it should not be the only coordination institution. And underpinning it all is the key difference from traditional systems that makes blockchains interesting. The layer 1 that underpins the whole system is the requirement for individual users to assent to any protocol changes and their freedom and credible threat to fork off if someone attempts to force changes on them that they consider hostile. Tightly coupled voting is also okay to have in some limited contexts. For example, despite its flaws, miners' ability to vote on the gas limit is a feature that has proven very beneficial on multiple occasions. The risk that miners will try to abuse their power may well be lower than the risk that any specific gas limit or block size limit hard-coded by the protocol on day one will end up leading to serious problems. And in that case, letting miners vote on the gas limit is a good thing. However, allowing miners or validators to vote on a few specific parameters that need to be rapidly changed from time to time is a very far cry from giving them arbitrary control over protocol rules or letting voting control validation. And these more expansive visions of on-chain governance have a much murkier potential, both in theory and in practice. Wow, that was a long one, but a great one on why tightly coupled token chain governance isn't as simple as we might think. Despite it being so elegant and seemingly simple, one token, one vote, the reality is that it's not. It's far more complicated. But before I get into that, I just want to say how much I love how this Web3 world mixes all of these different topics. Political science, economy, game theory, everything gets mixed up in the crypto world. And this is also my main counterpoint to when people say, where will jobs go in the near future, or when machine learning takes everything away? These are all new jobs that will be opening up. Every game will need an economist. Every application will need a political scientist. We will need to study the old to understand the new. And I think that's actually something that's missing from a lot of the teams working in Web3 at the moment, which is this background, this foundational knowledge of the history of political science and social sciences, because I think those come to the fore so powerfully in Web3. At the end of the day, these are all communities. We're building communities. We're using tokens to incentivize that. But at the core of it are humans, and humans work according to incentives. So we have to understand that and the core principles. Now, on-chain governance, for me, my main problem with it and my main take, and why I completely agree so much with Vitalik on this, is that on-chain governance simply means that you're handing over control of the protocol of this trustless state essentially to a few whales. And we usually assume in crypto world that, hey, this is good. They have the most skin in the game. They want what's best for the protocol. They want what's best for the token. They wouldn't vote against the long-term interests. That's not actually always the case. In history, we see this play out all the time, where you would think the highest levels of society have the most to lose right before a revolution, and they never make the appropriate decisions that prevent that, because that's just not how we're built. And so the assumption of giving things over and giving control and trust over to the whales in a system that's meant to be trustless needs to be taken more with a grain of salt. And we have to think about that also on layer 1 and also on layer 2. Because at layer 1, and Vitalik touches on this at the beginning of this article, even though it's not the main point, there is an assumption for many protocols, many of the higher TPS protocols, of an honest node assumption, where sure, they're never going to update the protocol to something that'll harm everyone. But that's not something that Bitcoin maxis or Ethereum maxis believe makes sense. No, you have to run your own node, own your own node, not your crypto. It's that kind of mindset, because you can't trust the honest majority. You don't know if they're honest. You don't know if they'll force some protocol upgrade that will harm you, that will tax you, that will devalue your tokens. And the whole point of Web3, of crypto, is self-sovereignty. And that means knowing what's on the level 1, knowing what's on layer 1. But going back to layer 2 and the token governance and tightly coupled and decoupled, yes, at the end of the day, we are a human society built with human structures, and communication doesn't just happen on chain. It happens on social media and the news, writing, books, ideas, podcasts, all kinds of things like that. The Bankless team always likes to say, and I completely agree with them, that, yeah, they are part of the Ethereum community because they are helping form consensus. They are part of the Ethereum consensus mechanism. That's what having a loosely coupled governance structure means. But what really struck me was this quote from Slate Star Codex on how you want to structure, ideally, a governance mechanism, one that's not tightly coupled. And I just love this quote. Quote, "Find a couple of elegant systems that all optimize along different criteria, approximately aligned with human happiness, pit them off against each other in a structure of checks and balances." End quote. And that concept, that idea of finding different alignment systems, different governance systems, and having them run concurrently, kind of like the idea of having a House and a Senate and an executive branch, having those checks and balances and having them being decoupled enough and decentralized enough, that's what wins. And when it comes to token governance or on-chain governance or DAOs or really anything in the Web3 world, what might that look like? And I think the answer is much more complicated than the token governance that we have today. And just to kind of not to spoil things that I'm going to be reading on this topic, but that might look like proof of work in terms of what you contribute to an ecosystem, to a DAO, or proof of participation or of caring, and not in a physical sense, but in the digital sense. What does that look like in the digital world? In the physical world, we have lobbyists, we have protests, we have calling your congressman and your senator. In the digital sense, what does that look like? And we need better tools than Discord to manage this properly. But that's where the answer lies for proper, decentralized, autonomous organizations. Because today the reality is that most of these DAOs are not decentralized or autonomous. They're just organizations. They're just companies selling security tokens. And the reality is that to be decentralized, we need better on-chain governance. We need better loosely coupled on-chain governance or off-chain governance, but we need better governance systems that work, that take into account all of those digital aspects.